Hey guys, Miss Miklos here, and this lecture we are talking about writing equations of lines. And I'm actually going to teach you guys 3 different ways to write equations of lines. And just so you know, on our test, it will really be open-ended. I won't make you write in a specific manner, so you can kind of choose which way you like the best. So the whole purpose of these suggested practice problems is to just kind of get used to what way you think is the easiest for you. So our first type we call slope-intercept form, and you guys are really familiar with this, y equals mx plus b. So in order to write the equation, I need to replace m and I need to replace b, and that would give us our equation of a line. The second form that we see a lot, we call standard form. Okay, and we talked about this in our last lecture, but that would be ax plus by equals c. And the big thing with this is that a and b cannot be fractions. Okay, so whenever we're writing in standard form, we know a and b have to be integers. C could be a fraction, that's totally fine. But a and b are always going to be integers, so if we had something that was a fraction, we would need to multiply the entire equation by a value that would get rid of that fraction. And lastly, what I personally think is the easiest way most of the time, point-slope form, and my guess is this is the way that you guys probably are the least familiar with. Just depends on what your Algebra 1 curriculum was like. But in point-slope form, it is very helpful to use when we have a point. Okay, and the point would be represented by x sub 1 and y sub 1, and the slope, which would be represented by m. And what we will see is often when we're using point-slope form, we will use that to kind of get the equation into the right form, and then we will isolate y to get it into y equals mx plus b form, which is pretty simple to do. So we're going to start with a very basic problem here. It says write the equation of the line would be the directions. Obviously, I didn't write that out. But it says m equals 2 and the y-intercept is -4. This is a problem that I would use slope-intercept for because it's talking about the slope and the y-intercept. So all I'm going to have to do is replace m and b with those values that are given to us. So when I replace m and b, I get y equals 2x minus 4, and that would be our final answer. Now, let's say we were doing something that was multiple choice, for example, a homework quiz or a quiz in class, or your test even, and the only options were in standard form. The way that we would need to get this into standard form would be to get x and y on the same side. So one way we could do this, we could go ahead and subtract 2x. So I would have -2x plus y equals -4. Or the other way we could see this, often we'll see our x value as being positive. So if I multiply that entire thing by a -1, I would get 2x minus y equals 4. Okay, now if it's open-ended, any of these 3 answers would be great. I just want to show us how simple it is to convert from slope-intercept into standard form. A second type of problem that we will see, and this is going to become very important later on in this chapter, is looking at a graph and writing the equation. Now, once again, I think the easiest form to use would be slope-intercept form because I think it's pretty simple for us to look at this graph. Okay, and obviously I drew this out so it's not like the best graph ever, but we can clearly see what the y-intercept is and we can figure out what the slope is. So if we look, the y-intercept, we know that's when it crosses the y-axis. It looks like it's at -2. So I'm substituting -2 in for b. And then to figure out what our slope is, I need to figure out what is the rise over the run. So looking at this, I think that it's rising 3 and going to the right 1. Once again, it's rising from left to right, which means that it should be positive. So our slope here would be +3, and our equation would be y equals 3x minus 2. So once again, if I was going to convert this into standard form, and I want to stress, we don't have to do this. I just want to make us aware of how to do this in case answer choices are in the form of standard form, or if in the future, in a different class, for example, it made you write it in standard form. I will never force you to write it in standard form. Okay, so we know standard form is ax plus by equals c, so I need to somehow get this x onto the other side, so I would do that by subtracting 3x. So negative 3x plus y equals negative 2 would be one option. If I multiplied that whole thing by a negative 1, I would get 3x minus y equals 2. And once again, those would both be correct answers. So hopefully that just kind of explains how to convert into standard form. From here on out, I'm not going to go through that at all. I think we can understand how to do that. So number 3, I'm actually going to model doing number 3 in two different ways. The first is going to be the way that you guys are probably the most familiar with, which is y equals mx plus b. So if I'm using this model, the very first thing that I would do is substitute the slope in for m. And now I'm going to substitute in the ordered pairs for x and for y. So I'm going to write that, 4 equals 2/3 times negative 3 plus b. So our goal now is to isolate b. So I'm going to simplify this. 2/3 times negative 3 is negative 2. So I get 6 equals b. So here's the key thing. That is not my answer. My answer needs to be an equation of a line. So it'd be y equals 2/3 x plus 6. And if you prefer doing it that way, that is totally fine. Okay, I just want to introduce you guys to point-slope form, because in a lot of ways, I think this is actually easier. So in point-slope form, what I'm going to go ahead and do here, I need to substitute in my ordered pair. I also need to substitute in my slope. So I have y minus 4 equals 2/3 times the quantity x minus negative 3. So I really have y minus 4 equals, okay, I'm just going to rewrite this as x plus 3. And then I need to distribute that 2/3. So I get y minus 4 equals 2/3 x plus 2. Now when I add 4, I get y equals 2/3 x plus 6. Notice I got this same exact answer. It does not matter which of these two methods we use. The reason why I like point-slope form, I just think it's nice that my actual answer is the equation instead of my answer being the y-intercept and then having to rewrite it. Okay, so from here on out, I'm only going to use one particular method. I just want to stress, you guys have a choice. You can do whatever you want. Okay, so number 4, this is another example when we have a slope and an ordered pair. I just made this one a little bit trickier because I gave us a fraction. I'm only going to do this one way this time, so I'm going to use point-slope form. So I'm going to do y minus 4 equals negative 8 times x minus 1/2. When I distribute the negative 8, I get negative 8x plus 4. Now I would need to add 4 to both sides. And I have y equals negative 8x plus 8. And that would be my final answer. Okay, so let's get into some tougher problems now. I think the toughest problems that we have to deal with are parallel and perpendicular. And we've already talked about the fact that parallel lines have the same slope, perpendicular lines have opposite reciprocals. Okay, so in this problem, they give us an ordered pair, and there's really two different things we need to do. I need to, first of all, for part A here, figure out what should be the slope of our new line. I know that this is the ordered pair it's going through, and I'm going to get the slope right here based off of that number. Since it's parallel, we know slopes are the same, so my slope is going to be 2. At this point, this problem is identical to the 2 previous examples. So I'm using point slope form, and I would do y minus 3 equals 2 times x plus 2, because it's minus a negative. When I distribute, I get 2x plus 4. So I have y equals 2x plus 7. Now we would need to go ahead and do part B. Once again, I know it's going through negative 2, 3. I need to figure out what is the slope that is perpendicular to 2. We know perpendicular slopes are the opposite reciprocal. So opposite means that it would be negative. The reciprocal of 2 is 1/2. So I'm using point slope form again. So I'm going to do y minus 3 equals negative 1/2 times x plus 2. So I have y minus 3 equals negative 1/2 x minus 1. This time, when I add 3 to both sides, I get y equals negative 1/2 x plus 2. And this would be our new equation. Okay, so I'm going to go through one more parallel perpendicular, and in this case, it is just perpendicular, and what makes this one a little bit different is that our original equation is not in slope-intercept form. So in order to find the slope, there are 2 things we can do. I can either isolate y and get it into slope-intercept form, or we can remember that in standard form, the slope is the opposite of a over b. So in this case, I'm going to use that because I remembered that. So it's going to be the opposite of 3 over negative 1, which is positive 3. So if the slope is positive 3, the perpendicular slope would be the opposite reciprocal, which would be negative 1/3. So I'm going to set up my point slope form here, and I'm going to write y minus 1 equals negative 1/3 times x plus 3, because it's minus negative 3. When I distribute the negative 1/3, I get negative 1/3 x minus 1. When I add, there we go, moving up here. When I add 1 to both sides, I get 0, so my answer here is y equals 1/3 x. I'm sorry, y equals negative 1/3 x. Apparently I can't read. There we go. And the last example that we're going to go through, this one is just a little bit different because it gives us 2 points, but it doesn't give us a slope. But I know all you math scholars out there remember that we can use this formula to find the slope of any 2 points. So I'm going to go ahead and do the slope is equal to 2 minus 5 over 4 minus 1, which is negative 3 over 3. I know I always need to reduce, so I get negative 1. So I'm going to go ahead and write y minus y sub 1 equals m times x minus x sub 1. And I want to stress once again that even though I'm using point slope form, we could use any of the methods that we talked about in this particular lecture. Now, I have some options here. I have 2 different ordered pairs, and I can choose either one of those to substitute in for x sub 1 and y sub 1. I normally choose the one that looks the easiest. Here, I think they look pretty similar. They're both smaller numbers, and both numbers are positive. So I'm just going to go with that very first one. So I have y minus 5 equals negative 1 times x minus 1. When I distribute the negative, I get negative x plus 1. And then when I add 5 to both sides, I get y equals negative x plus 6. Okay, so definitely, if I understand these steps, it's pretty straightforward how to do this. However, in past years, for some strange reason, this has always been a difficult topic for our chapter test. So I just want to stress, take your time on these problems. Make sure that you are distributing negatives and just checking every little step.